Test 1, 2, 3. Testing into AI.
beyond its beaches and rich culture, here, people are digitally adept and early adopters of new innovations. This is all supported by world-class digital infrastructure, here across its more than 7,000 islands, making it the ideal digital market destination, the Philippines.
IPv4.global, from Hilco Stream Bank. Backed by Hilco Global, IPv4.global has completed thousands of transfers. Our online marketplace serves address blocks and ASNs of all sizes and regions. Transparent, experienced, reliable. IPv4.global.
You don't call your mum via a chain of other people's phones. So why would your Australian network be any different? One Internet Exchange Service makes single-point national connectivity in the Australian market as simple as IAA. Carrier-neutral, high-performance, unmetered peering from IAA. Because your users deserve it.
In Asia, the IP address management is managed by an organization called APNIC. Then, APNIC appointed IDNIC, APG, to run the IP address management process, especially in Indonesia.
Team Cymru delivers no-cost threat monitoring to internet service providers and hosting providers who partner with us. Nimbus Threat Monitor gives you near real-time threat detection, illuminating the compromised assets on your network and those of your clients by correlating your network flows with our world-class IP reputation data. Saving and improving lives is Team Cymru's mission, and making the internet a safer place is integral to that mission. Take advantage of our peer signal threat detection today.
So good morning, everyone. Welcome to day 2 of APRICOT. So we'll just have turned the recording on. So as with yesterday, these sessions will all be recorded. So if you want to come back to them and see what was going on or see what was said, you can listen to the recordings in the next few days or so once they're on the website. So before we start, I don't know, it's looking like a very interesting session for this morning. We have the Zoom chat window on the bottom right. So if you have any questions for the speakers, the session chair will be monitoring those. So please ask your questions there. Otherwise, I think I can hand everything over to Maz, who will be your session chair for this morning. Maz, it is all yours.
Thank you very much, Philip. Welcome everyone to the APOPS session. This is a forum for operators in APAC region. As you already know, we are using Zoom, so please mute yourself during the session unless you need to. If you want to ask questions, please ask them in the Zoom chat or conference chat, or you can pick the reaction button, wave your hand, and we will notice that as well. Now then, let's welcome our first speaker, Danny Pinto. He will talk about programmable coherent optics in IP backbones is real. Danny, you have about 15 minutes. Over to you, Danny.
Thanks, Maz. Able to hear me well?
Yes.
Okay, I'm just going to share my screen.
Yep, it's showing.
Okay. Good. I mean, yeah, okay. First of all, thank you, Maz. Thanks, APRICOT Program Committee, for the opportunity and privilege to be here, and privilege to also present on pluggable coherent optics in IP backbones. This is the experiences of Colt using this technology. I'm privileged to be working with a wonderful set of packet IP and optical engineers in realizing this agenda in Colt. And the important thing is it's all their work. I'm just a mouthpiece here. So diving into the broad agenda, we just take it in 3 parts. We look at why we do this, what's the reasons of doing this, and then get into what we're doing in terms of coherent optics or IPO DWDM with this technology, and also how this technology complements the other winning combination to achieve data center optimization. Okay, so it's always good to really start a presentation with a network graph. The graph is always growing, whether you're running a business where network is $ per bits or $ per clicks, it's always growing. You can look at endpoints changing, you can look at hybrid working, you look at internet as a preferred WAN today with SD-WAN. So there's only one thing to look at here. The killer app continues to be bandwidth, more and more bandwidth. And the decisions for higher speed adoption has been the same good reasons, right? When you went from 1 gig to 10 gig or 10 gig to 100 gig, it's always going to be about network port and scale. And it's also, even if the traffic is not growing, I think it's how are you going to manage big pipes? Pipes in terms of load sharing, ECMP, large flows. I think you still have those fundamental challenges which you had in the past. And the important thing is adoption to 400 gig or any higher speed, the timing is crucial. Do you have the technology at the right cost? Can you adopt this technology with the right amount of validation, supply chain delays these days, and of course, the time it takes to deploy this. So if you just put this into a perspective from an internet operator point of view, this very old kind of concept of peering cost model. We always turn up BGP sessions, we call peering is settlement free, but under the hood, there is a cost for peering. There's a cost for internet over backbones. So taking it from left to right, you have a backbone which is consistent of network devices, electronics, and high-speed connectivity, up to 100 gig, 400 gig, looking up to the future. But it's also about how to connect into data center co-locations, what infrastructure you put there. The cost of the co-location power space is kind of an important piece that we always miss. And of course, the cost of really connecting to other internet operators, other internet exchange points, or private peering. So the three important things are, of course, the network device and ports, the transport and protocol. But also we also need to consider the human cost to operating peering, the smart people in your companies that really turn up peerings, manage them, do traffic analysis. Also, there is growth on the internet towards the edge. We're seeing kind of motivations in many internet exchanges, like in links, you can go 4 times 100 gig or 400 gig at double the cost, not 4 times the cost. So there's incentive to move to higher bandwidth. But from a core point of view, we're focusing on 2 major points. One is, how do you really grow your network to achieve the bandwidth scale with the network electronics and the core backbone transport? Because the pricing for customers is coming down, falling off the cliff in many regions in Asia. But how do you really manage the electronics and backbone cost? And the second important thing is sustainability. How do you build environments in the future which consume less power and space at an optimized cost? And those are 2 focus areas for code. Building core networks in the past, and every organization, every network operator has organizations which has optical, fiber, and IP teams working one over another with the networks, right? It's traditionally the organization mimics your the topology stack, and there's clear kind of handoffs between IP or packet networks and the optical network, clear port demarcations. And what happens is, like, the innovation and the investment is always happening within the boundaries, within the optical layer, within the packet layer, and you're not able to adopt kind of innovation between these layers. So the outcome is what we really see. When you go deploy a new POP or a greenfield or a brownfield network, you're adding new gear, your deployment looks like this. A big fat routers, 10 slot, 20 slots in the past, and you have just 2 slots used. You're pretty much having a lot of free slots there. And you have a lot of shiny optical gear with a lot of cards, transponder, DWDM, amplifiers, and a whole lot of clean fiber patching. So you always are amazed with the full rack of telco toys that we have in our racks, right? So that is the way we will build our networks in the past. And the new enablers are going to be, from a core point of view, is 3 different innovations. One is the advent of open optical networks, coherent pluggable standards today, and of course, the root of silicon in evolution or innovation. So we're going to look at how we use the IP backbone optimization using optical or open optical networks, which happens to be in the earlier days called IP or DWDM, and this is real now. As router jockeys and router engineers, we always look at routers having ports, and the ports connected into an optical system. And the optical system is traditional optical network environment. It's a closed environment run by an optical team or a transport team. And under the hood, you don't care much about it as a router engineer, but you always build pipes across this network, and you're building and handing off ports across these optical environments. So under the hood, these are elements which are transponders, multiplexers, optical line systems, which make up this environment. And the fact is, it's a closed environment. You don't have any kind of bottom-up view of what's the cost or what's the kind of functionality that you can break away. So in the past, you used to have concepts like IP or DWDM, which meant you need to move the transponder. The transponder is which one is the component that takes the client signals and then maps it into the DWDM network. So the transponder, the earlier days of IP or DWDM, the transponder was put as a line card in the routers. What that meant was your router and the technology of optical needs to be from the same vendor. So ultimately, you used to work with very closed environments with less amount of disruption and innovation. Now, with the advent of open networking in the last few years, what has happened is the optical line system, the DWDM environment, is partially disaggregated. What's happening is your transponder can be from another vendor. So you can match an optical transponder to a line system from another vendor B. So what you can achieve is bringing best-in-breed technologies into this particular space. Now, this is kind of the disruptive area where you're able to really bring in new technologies at a much compact scale. You take it to the next step. You move the transponder, which interfaces the router, into the optics, and that's what is called as coherent optics. The coherent optics is moving the transponder functionality totally into the router optics. the same line card where you run your standard optics, you could add a coherent optics. And what it means that you're eliminating just not transponders, you're eliminating the need for additional gray optics, back-to-back optics to the transponder in the old days. So, and this has been possible with the evolution in silicon, where we're going towards 7 nanometer and 5 nanometer designs. So this really brings the cost down of electronics required for your backbone transport. Looking at what we have in kind of the optics, you have the traditional optics for 100 gig or 400 gig, the SR, DR, and LR, and ER based on the distance span you want to cover. But you also have the opportunity to look at coherent optics, which has a transponder functionality, which can be used from 10 to 120 kilometers or 120 kilometers to 1,000 kilometers using the 400 ZR+. These are coherent optical modules, which are standards, which are approved and implemented as per OpenZR+ or OIF. These are in small pluggable factor. You have different form factors available in the market. Of course, it has different thermal characteristics. The important thing, the cost performance. You're getting the 400 gig at the very lowest cost point with this particular technology. And the interesting piece is like you can really also run not just full 400 gig for needs of better spectral or optical efficiency. You can also turn up 300 gig or 200 gig if required. So the different form factors available today with different power and thermal efficiencies to really look at these particular distance spans. But the important thing is, from a cold point of view, we're focusing on QSFP-DD, which allows us to achieve the right router design. Now, looking at the use cases for cold, there are broadly two use cases that we are really looking at. The platform remains the same. The core aggregation access topology remains the same. They're using coherent optics within the core network for the 100 to 600 kilometer range. That's a 400 gig ZR+, and the 400 gig ZR, we're using it for covering over 90% of use cases where we have to drive the router connectivity between backbones, between peering locations, between aggregation and core up to 40 kilometers. So this is where our use cases are. So this gives us an incredible reduction in transport costs. So the transport cost used to be X in 2016, and with adoption and improvements in electronics, we have been able to reduce it, but we see a drastic reduction into the cost of 70% improvement in 100 gig bandwidth addition. So this is being enabled by these coherent pluggable modules. And you also can see the cost is shifting from the optical side into the router module. And the topic which I want to really cover off is the adoption of 400 ZR+ also drives the new silicon in routers, right? So you have available in the market different vendors delivering new router models, and these router models are using the new technologies in silicon, the 16 nanometer, driving towards the 7 nanometer, 5 nanometer designs. So you're able to get the capacity of 1 or 10 terabits or more within a single RU of a rack, and this is going to be key. And what you could do really is really look at the growth of your network and really start to really look at core access and aggregation, fit in the right components or the right devices with the right scale for the right purpose. You could move the ones which need high IP or NPUs, as it's called, high QoS features, high FIB ACL features into a router on a stick model. And what becomes very interesting is that the smallest form factor with 400 gig optics at QSFP-DD allows us to achieve this design. So the key reason is your data center cost is very high. The data center power space is going to be a topic of discussion for next few years. It's pretty much flat over the last few years. And whilst the pricing is going down for bandwidth connectivity, your cost for colos probably is going to be remaining high. And what you can really do is look at cost avoidance in the future with not continue to deploy big fat boxes in your racks, rather than start to really look at the combination of coherent modules and smaller silicon routers and do a kind of optimization of existing racks, or go towards avoidance of future network gears. That's what we are achieving in cold. We have relentless focus on cost avoidance by optimizing the colo footprint and also achieving what is our primary target of sustainability of greener networking, where we're reducing the power for 100 gig by around 97%. So this is something which we already did in Europe. In a core network and heart of our network, we tested with the London Brussels, which is a 439 kilometer. We use coherent optics with our new silicon routers. and we're able to complete 80% of our core backbone in Europe using this technology. Some of the links are more than 600 kilometers. We're not stretching the technology at this point of time, so we're leaving it to understanding and maturity of this technology to really look at these links also. So key learnings, you can look at the coherent optical modules and your router modules and look at also your optical layer. I need to pay attention to standards and implementations. You can work on 400 gig ZR plus at 200 gig, 300 gig baud rates also, and you need to really look at the fine print in the documents, right? So the 400 gig ZR plus, which goes for more than up to 600 kilometers, I may work on only some ports, and shouldn't be a really problem. So the key thing is human networking. Human networking is working with your optical peers who are generally like physicists, where the router jockeys are more towards software defined and automation. You need to really let to understand what is happening in the intersection of science and technology, both on to understand the optical layer, but also need to understand that your optical layer is now started really working in your routers. So you need to look at the different parameters like bare, Q margin, OSNR to really look at what these mean for your network now. So our next deployment is going to be in Asia, in Japan in 2023. We're looking at use cases in Tokyo Metro and also building a backbone on 400 gig ZR plus between Tokyo and Osaka. So in summary, the transition to 400 gig comes with new opportunities. We have the opportunity to latch on to new disruptive technologies, and the topics like IPO, DWDM, whether it's called IP integration, disaggregation, or convergence, is now real. So transition to 400 gig can come up with a renewed approach for design, building, and operating IP networks. So this is what the community is about, building a stable, secure, and scalable internet. Thank you.
Thanks, Danny. We have one question on the chat window. So finally, convergence of the coherent DWDM tech and the routing platform is an affordable reality?
Yes, I think I showed you the graph where the cost of putting in 100 gig is 70% lesser than yesterday. So this technology is not only performing at bandwidth, but also at a cost point of view. So it is real, both at cost and performance.
Thank you very much. Tashi, thanks for questioning. Okay, thanks very much. Then let's move on. Next speaker, we'll have Jeff Houston. He will talk about routing in 2021. Jeff, please make sure you have 20 minutes and no more. Over to you, Jeff.
Would I ever speak for longer, Maz? Would I? Look, it's a pleasure to be here this afternoon, this morning, whatever your time zone might be. And today, what I would like to do, and you may have seen it in previous years, is actually look at the internet's interdomain routing system and look at what's changed over the last 12 months and take a long, hard look at BGP in 2021. So I'll do this very quickly in 20 minutes and look at V4, V6 and FID projections, some issues around churn and some conclusions. Look, all of the internet is visible in the routing system. And oddly enough, if you look at the routing system over time, you see all of the internet's history. And so here is a rather cute graph. It's the number of entries in the BGP routing table in IPv4 taken every couple of hours since 1994. And so it's an incredible amount of history of the internet compressed into just one slide. Here's where we thought we had a problem because we're going to run out of routing space on our IBM PCXT routers in the National Science Foundation, and great sigh of relief, we fixed it with the introduction of BGP4 and CIDR, and disaster was averted. Yeah, right. It seems such small scale now. The next big event was actually 2000, 2001, the great internet boom and bust. We were on an exponential growth curve as we sort of turned over the millennium, and then everything just fell apart, and that growth spurt kind of dropped apart, and we thought disaster had hit us. It wasn't. The inexorable growth just continued. And quite frankly, it was around the mid-noughties with the DSL consumer market because if any of you remember dial-up modems, they really were an invention from hell. DSL made this whole thing into a consumer reality, but at the same time and around that area, the iPhone came out. And all of a sudden, mobile started to complement the wired network, and the internet became a consumer reality. At that stage, we were building as fast as we could, and that inexorable uptrend was actually about the pace we could build, not the pace consumers wanted to use it. So we were in the midst of a massive build out, and then we ran out of addresses. 2011 was when we hit the first parts of the crunch. And over the next few years, although you wouldn't notice it from the routing table, we've been running on progressively fewer and fewer resources. Why are there multiple lines? Because I'm looking at a route aggregator, looking at the collection of routes coming in from route views and looking at every peer. And interestingly, as we look closely at this, and here's the last 12 months, everybody sees a different internet. Everyone sees a subtly different collection of routes. By the end of 2021, some of the smaller ones were seeing just 860,000 routes, while others were seeing another 60,000 extra routes. So interestingly, although the job of BGP is to flood routing information all over the internet, so everybody sees the same network, the job of you network operators is to make sure that doesn't happen. Well done. And what we get is actually everyone sees a subtly different network, which I find comical and curiously bizarre in so many ways. On the whole, the network just grew, even though there were very few new v4 addresses. Slight downtick in May, slight uptick in November, but on the whole, it just grew. There were a few sort of minor surprises, although it looks dramatic when you actually count the number of addresses. In reality, it was pretty banal. An extra 218 million addresses got advertised last year, but most of them were actually the advertisement of old US Department of Defense /8s, which started to be advertised first by a contractor and then by the MilNet itself, kind of filling in the blank gaps. Although no official reason has been given, I think part of it was there was some concern over the address scarcity issues, and the DoD was kind of worried about folk camping on their addresses. So on the principle of use it or lose it, they decided to advertise it to show that it really was their addresses. So the amount of change in advertised, it went up by 218 million, and those addresses which were previously unadvertised, and they were advertised at the start of 2021 and again around April, that came down in terms of what I would call recovered normally. The RIRs themselves allocated a further 24 million addresses, most of them from around APRICOT and the reserved pools. Those large /8 pools are still happening. So what actually happened? Well, in terms of growth, 40,000 new entries is for V4 not a big deal. The growth is slowing down. By and large, we're up to around 900,000 entries by the end of the year. That growth rate, 40,000 last year, was 52,000 the year before. So it's a pretty big slowdown. And interestingly, the number of new networks joining the V4 network has dropped by 50%. We grew by 3,400 in 2020. We grew by 2,400 last year. The topology of the network, much the same. So on the whole, V4 is not growing as fast as it used to. It's just ticking along. What about V6? This is where there is real growth. This is the up and to the right exponential curve growth. It's again route views. It's a slightly shorter view from January 2004. There wasn't much data before then. V4 exhaustion didn't really show much in these figures. When we actually ran out in 2011, nothing much happened. But the biggest growth, as you can see, is in the last couple of years. And even in 2021, it's not a banal picture. There are a number of big events. Firstly, in V6, no one quite knows what the expected route size is. And there are a whole bunch of folk who seem to think that we should be routing /48s. How many /48s are there in V6? More than you'd care to worry about. We can't all use /48s. The routers will mean you're talking trillions of routes. And so occasionally folk deaggregate. It happened in April. Sometimes, as happened in November, they deaggregate and then think better of it. But there are these dramatic events where not a largish block, a /29 gets deaggregated into /48s, and the thing just explodes for a while. The other interesting one was China's FutureNet research platform that happened mid-year, where they have a little over 5,000, I think, autonomous system numbers and a similar number of /32s. And they advertise one AS and one /32, and they do that 5,000 times. When that hit the routing system, you see that step jump because, well, the world needs to know about this, doesn't it? So the world does. It hit the routing systems. Interestingly, for V6, although 40,000 new entries in V4 is sort of banal, 40,000 entries in V6 is yahoo, this is amazing. So it's all a matter of relativity, isn't it? So we're growing at around 41,000. More use of /48s, which quite frankly is unsustainable. We don't have hardware in the foreseeable future that could cope with everyone doing 48s. It just won't work. So, whatever you're doing, stop it. But there are more networks advertising V6 prefixes, and that's great. So if you're going to buy a router this year, if you're looking at how big should it be, maybe you should worry about fib projections. So let's look a little bit about the projections of all of this. The V4 routing table. I've given you 3 best fits to the last 2 years of data, 2020 through to 2022. I think it's possible to put an exponential curve against it, but quite frankly, it doesn't make much sense. Even if I use a polynomial, order x squared, doesn't make much sense. Right now, the best fit projection is linear, which kind of matches the fact that realistically, the only way to advertise more routes is to slice and dice and advertise finer and finer and finer prefixes until the entire V4 internet just simply becomes a sea of /24s. Already more than half of the routing table is /24s, and it's just going to get more and more like that. So as far as I can see, it looks like we're growing at approximately 44,000 new routes a year, and that will keep on going at a linear fashion. And so by 2027, 5 years out from now, you're going to need for the external, the default-free part of the routing space, 1.15, 1,150,000 entries in your fib table, which in relative terms is actually not much more than where we are today. 900,000 to 150,000 million is really only 200,000 more. So nothing to panic about. Hopefully you have that much space already. That's easy. V6, that's not easy. Now, this is doubling every 2 years, which is uncomfortably close to the residual bits of Moore's law if you still think Moore's law is holding up, the digital universe. There are those who are getting pretty pessimistic about Moore's law, saying we've reached the end of that road, and they could well be right. It's getting very, very hard to jam more gates into silicon, and even the few chip fab factories, and there are only 2 that are doing very fine track widths, are having a lot of trouble keeping up. And so the V6 table is going to grow, and it's going to double every 2 years. And so when I look 5 years out, it too will be close to 1 million entries, 850,000. And that exponential scale is, to my mind, far more credible than a linear scale. I just can't see a linear scale happening. Now, don't forget that these V6 entries are 128 bits wide, even though, and this is one of these wacko contradictions that V6 is full of, there's only 64 bits of routing space, and the other 64 bits are actually interface identifiers. The poor old router vendors are actually doing the full 128-bit wide lookups. And so those TCAMs are actually 4 times as wide in 6 as they are in 4. So the amount of memory space in TCAM memory, the bit that, costs an arm, a leg, and 3 fortunes, is actually 4 times more expensive in terms of a V6 entry as compared to a V4 entry. And so those million odd entries will take 4 times as much memory in 6. So if you were doing a fib allocation of most of it's V4 and a tiny bit's V6, in 5 years' time, it will be, this is V6 and this over here is V4, because that's about the only way they're going to fit in. So, you know, in conclusion, the absolute size in the V6 routing table is growing a whole lot faster. They'll gain the same size in lookup terms in 2 years' time, and after that, V6 will start up taking more space. Should we give up? Will BGP keep on working? And the answer is, well, BGP really hasn't got a problem. It really, really hasn't. BGP is going to route that size of network just fine. Will your routers live with it? Well, more than likely, but you will need a fair deal of line space, line forwarding space, if that's the way you're doing your hardware. But as they say, it's not the size, it's what you do with it that really matters. And in this case, we need to look at the dynamic behavior of routing. There is no doubt that distance vector algorithm is the worst possible distributed routing algorithm to use. It's just noisy. And oddly enough, it always strikes me as a matter of one of those miracles of the internet that BGP is still largely under control. This is a plot of the daily number of updates in the V4 network as seen by my routing collector, 1AS, just a couple of eBGP feeds. And I just look at the number of updates and the number of withdrawals. You'd think as the network grows, the number of withdrawals would go bigger and bigger and bigger and bigger because, you know, there's more space and more people doing stupid things. But the number of withdrawals is actually really constant. It's scale free. There's a PhD in it for anyone who can explain why, because nobody knows, literally nobody knows. The next sort of it's the green lines, which is the number of announcements. And what you actually find again is that right up until 2013, the number of updates was constant, scale free. 2013 was a really odd year. It doubled, but then it stayed constant. And for the next 7 odd years, it was around 100,000 updates a day, scale free. The network was growing, but the number of updates weren't. Now in 2019, again, it just went into this period of huge instability. Someone stopped looking. Naughty. And we were seeing a whole bunch of dynamic activity across a much larger space. But interestingly, in the last few months of 2021, it started to come back under control again. No idea why. None at all. But the good news is that if we then look at this from performance terms, how long does it take for BGP to agree of the new route when a route gets updated? That's back down to 50 seconds, which is the same number that it was 10 years ago. So we've basically built the network up from 200,000 entries to 1 million, yet its dynamic performance is about the same. Now, that one we know why. And the real answer is the network that we're building is a bit like a collapsing star. What goes on is as we add more stuff into the network, it doesn't get bigger. It doesn't expand. We're just increasing the density and maintaining the diameter. And for distance vector routing algorithms, it's the diameter that's that key feature, amongst others. And as long as you can keep that diameter under control, the whole network itself remains largely well behaved. And for convergence of 50 seconds, that's brilliant. So, you know, V4, just fine. The other thing, by the way, is the naughty boy room or naughty boy and girl room. 20% of prefixes generate 80% of all updates. You know who you are. Stop it. 5% of all origin networks do 80% of these updates. We know who you are. You know who you are. Don't do this. It's just annoying. This network could be a whole bunch better and getting rid of most of that noise if you simply bothered to look at what your router configs are actually doing. What about V6? Well, it's a completely different story. Here, the orange, it's a log scale now because V6 is growing. So to make it sort of fit in a graph and not be exponentially silly, I've made it a log scale so it's turned linear. The number of updates, the announcements, is actually more than the number of prefixes. the network is incredibly noisy. And whereas in V4, the number of withdrawals is scale-free, in V6, the number of withdrawals is increasing as a proportion of the network size. So whatever we're doing in V4, we're doing the exact opposite in V6. And the number of unstable prefixes tends to be growing faster than the size of the update table. Whatever we're doing it wrong. Now, there's convergence performance. Well, that is getting better. That's the one good thing. But why is this? Now, I would actually offer the view that we said for a long time in packet switch networking that network state, virtual circuits, MPLS, any kind of tunneling is evil. We don't know what we're doing, and the public internet, we get it wrong all the time, and it creates massive instability. There is an awful lot of tunneling in V6 even today. There is an awful lot of really surprising and incredibly bad routing going on in V6. And because it's dual stack, as operators, nobody looks at V6. And so we put up with ghastly performance because none of you operators are looking. We know how to do a better job, but in V6, nobody cares. And then we wonder why this transition takes so long, because any poor soul that's willing to actually run their network on V6 is dicing with death, because V6 only will act terribly. We also have a look at where's all these updates coming from. In V6, instability is actually concentrated in a small number of networks who are pathologically bad. You know who you are. We know who you are. Please, just don't do it anymore. The network will thank you. So conclusions. Look, we're not under any great pressure. The sky is not falling. There are a small number of routers and networks that are just pathologically unstable. Thank you so much. But for the rest of this, the stuff is actually surprisingly stable most of the time. But there are some things that you need to actually do. Firstly, look at your routers and make sure you know what its limits are. Look at its fib capacity and look at your packet capacity in the fault-free parts, and make sure you have enough line card capacity to handle the routing tables. Look at your allocation by V4 and V6. You may need to adjust it. V6 is growing faster than you thought, because doubling every 2 years is a surprisingly fast growth. You don't need to carry all the routes everywhere. Default is your friend. Prune, 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 and you will have a lot less of a headache. Carrying a full routing table isn't strictly necessary over at the stub ends. It's more important if you're a transit hub and you're carrying a whole bunch of alternate routes and paths. Out at the edge, yeah, don't worry about it. And as a sort of a look to the future, it's kind of crazy to put all these routes in all those line cards. Any large-scale transit network finds that it's dealing with about 500 routes for 99% of the traffic. The other 999,500 route entries are sitting in your line cards unused. And at some point, we're going to get into hot caching on the line cards, where you do small, high-speed hot caching in the fib cards. And so if you're going to Google, it's really fast. If you're going to me and you've never been there before, the router's going to say, I better load that up into my cache. Hang on a second, packet. Oh, you've dropped in the process. Sorry about that. But we are going to do hot caching, because the way we're doing it at the moment only works if hardware is cheap. It's not, this doesn't scale, we're going to have to change things. So those are a few suggestions, and I'm out of time. There is a bigger pack. If you're really interested in this, there's a whole lot more detail, but, time's out, so I'm not going to do it here and now. I'll hand it back to you, Maz. Was that the right time?
Yes. Yeah, a little bit. So we have 3 questions.
Sure.
How much of the IPv6/48 explosion is down to RIR allocation versus LIR deaggregation?
The average allocation size in the RIPE NCC is a /29. All the other RIRs, the average allocation size is a /32. The /48 pollution is everybody else's fault, okay? You're doing it to yourselves. Well done.
Thank you.
Next question.
How many routers have to keep full routes?
Gee, what a great, no, realistically, and this is almost like an RPKR style question, the core of the internet that needs to do switching. Of the 70,000 ASs in V4, most of them attach to a small core of 6,000 networks. But even those 6,000 networks aren't really the big core. If you actually look at connectivity, you'll find that there's really only 7 networks that glue all the others together. If you look at neighbors and so on, you'll actually find the number of ASs with more than 1,000 AS peers is a really small set. See the bigger pack, see other articles, whatever. And so how many? I don't know how many routers, but I would guess that if you said there are 10 networks whose internal infrastructure needs to handle a full routing table, you actually wouldn't be far off the truth.
Thanks. The last question, how do RIRs consider the IPv6 allocations in order to deal with the explosions?
I think it's been said many times, although with APRICOT it's getting a little bit clouded, the RIRs have always said, we're not the routing police. We give you addresses, after that you're on your own. There is some effort to make sure that the allocations are routable. And so we don't hand out /30s and /31s, because on the whole in V4, if you tried to actually advertise that, you're going nowhere. And so we are mindful of routing allocation and operational policies in terms of minimum allocations. But beyond that, the address policy process that you folk are all part of kind of agreed on these kind of stable points of allocation. And one of them is to get a /32 in most RIRs and a /29 in RIPE with the RIPE NCC is relatively straightforward. And that's kind of the lingua franca of allocations. But operationally, you've slipped into this bad habit of actually advertising more specifics because, well, I don't know. You must know, you're doing it. And I don't think you know what you're doing. I think you're doing it because you've done it for years and who cares? I actually don't think you've understood what you're trying to achieve. And that's why more than half in V4 and 66% of the route advertisements in V6 are actually more specifics. And the vast majority of those have the same path as the aggregate. So it's not traffic engineering, it's just senseless routing vandalism. Now, it's your routers, it's your money, you're paying for this. And so it's sort of self-inflicted senseless routing vandalism. And searching to the RIRs to go, RIRs, help us to stop being bad to ourselves. It's kind of, no. You've got to do it yourselves. You're responsible. Think carefully about how you want routing to happen. Judicious use of defaults, very, very judicious use of more specifics. Try to limit the noise. Maximize and aggregate wherever you can. I'm sure the Chinese research network is a wonderful thing. It's great. I just don't know why the world needs to see those 5,000 separate prefixes that are actually all adjacent. They'd all be summarized inside a I don't know, 24 or 25. But we're seeing all the noise all the time. And then you wonder why at some point you need bigger, faster, better routers. That's why. So it's a solvable problem, but it's one of those places where it's up to you to solve it. No one's going to solve it for you, even including the RIRs. Is that a harsh enough lecture for you?
Yeah. Okay, thanks very much.
Thank you.
Time is limited, and I see Terry's hand up, but because of the time limitation, let's move on. Thanks, Jeff. Terry, you can leave your question in the chat, by the way. Okay, let's invite our final speaker, Seth Sean. He will talk about reducing IP address waste. Seth, you have about 15 minutes now. Over to you, Seth.
Okay, thank you. Can you hear me all right?
Yes.
Well, thank you very much. Yeah, I'll share my slides. Let's try. Can you see that all right?
Yes, perfect.
Thank you. So thank you very much for having me here. So I'm going to talk about our project. We have a sometimes controversial internet standards project and wanted to broaden the conversation about our efforts and ideas by presenting here at APRICOT. So this is a standards project created by John Gilmore with several other collaborators. And our proposal has to do with reducing the waste of several categories of IPv4 address space that have been historically reserved by asking implementers to change their implementations to treat these as valid global unicast address space. So a lot of context for some of the v4 practices and controversies in the previous presentation is, of course, the IPv4 address scarcity, where in 2011 or sooner or later than that, depending on how you want to measure it, as Jeff discussed, there was the IPv4 address space exhaustion event. And it's unfortunate because there's a considerable amount of IPv4 address space that has never been globally usable and has never been globally used. And that includes, of course, address space that may be reclaimed from historic allocations, but it also includes address space that was historically reserved. So we're proposing to unreserve some of that space and then to test how usable it could be. If it turns out that these addresses can be made usable, then eventually, some years from now, it will be possible to allocate them. So a lot of these decisions date back to the 1980s. Since I only have 15 minutes, I'm not going to try to recount all of the RFCs that made address space reservations, but of course at that time scarcity was a much less prominent concern. And so there were decisions taken in the 1980s that are still having their effects felt to this day. Some of those decisions, it turns out, were not that helpful, but they're preventing a lot of address space from being useful, even in a time of very, very, very acute IPv4 address scarcity. So we've proposed 4 internet drafts over at IETF, presented the first 2 at IETF 112, saw some controversy, and are hoping to present the other 2 at the upcoming IETF 113. So I'm going to talk very quickly about the kinds of addresses and some other policy considerations around this and some of the other conversations that have been going on. So one kind of address that's been going to waste is the lowest single IPv4 address space, the lowest individual IPv4 address in every subnet. So if we have a /24, Berkeley in the 1980s chose the lowest address, what would be the .0 of a /24 for broadcast. Other developers elsewhere chose the highest address, which would be the 255 in a /24. Eventually, the highest address won out in the recommendations, documentation, and standards, but the lowest address continued to be reserved explicitly for backwards compatibility with operating systems like 4.2 BSD that haven't existed and haven't been used on the internet for decades, with the result that we lose 1 address per subnet across the entire internet. So this is a very diffuse waste. It's also interesting that changing this under existing standards only has to be done on the LAN. It doesn't require changes, even with prior rules and interpretations anywhere else, because you're not allowed to assume the net mask of a distant network that you're not attached to. So that means that if you update your router and your LAN to treat these as non-broadcast, then the rest of the internet should be able to interoperate with it. You can see some examples of this in Amazon's EC2 reachability page, where they have various addresses that you can connect to see if you can reach EC2 networks, and a lot of them happen to be .0. And we don't know, of course, since we're not attached to their network, we don't know what the net masks are there. We don't know whether those are /24s that are willing to route those, whether those are more specific or less specific than a /24. And so this, unlike the other address space that I'm going to mention, is something that can be fixed unilaterally by end networks. Now, the largest category of addresses, and probably the most famous that's going to waste, is the experimental addresses, or reserved for future use, which are all of the addresses beginning at 240 on up. That is 2 to the 28 addresses, less 1 for the 255.255.255.255. There were lots of really good reasons to reserve these for future use in 1983. For example, there was a proposal that there would be further new addressing modes on top of multicast. There was a proposal that anycast or escape to larger address space would use dedicated address ranges. It turns out that that didn't happen, and yet 240/4 is still reserved. It's still reserved for future use, but new addressing modes and new uses of this address space are very unlikely to be invented now. Now, there was a proposal in 2008 to unreserve those addresses, and I'll talk a little bit about the consequences of that coming up. But another interesting one is 0/8, all of which is reserved due to a decision in 1981, which was for an ICMP-based auto-configuration mechanism, which was subsequently superseded by bootp and DHCP, which use only one of these 2 to the 24 addresses. The ICMP-based mechanism that would have used these addresses, and for which they continue to be reserved, was officially deprecated back in 1989. So again, we have 2 to the 24 addresses that are reserved for a system specified in 1981 and deprecated in 1989 that, to my knowledge, has never been implemented. And some of you may have seen on some of your local NOG lists or elsewhere some debate about our observation that we also have a lot more loopback addresses in 127/8 than we need. And in particular, 2 to the 24 addresses were reserved back in 1986 for loopback, which contrasts with IPv6's decision to use only one single loopback address, the :1. It's not very common. In fact, we have only found one example so far that people have shared with us for addresses out of 127.0/16 to be used for loopback at all. Multicast also is a possible point of discussion, but we don't have an internet draft about that. So I'm not going to talk about that right now. So this adds up to quite a bit of the IPv4 address space. It adds up to 6 to 7% of all of IPv4, in addition to a single address per subnet internet-wide if we redefine the lowest address to no longer be a broadcast address. Interestingly, there is a lot of software support for this already. So in 2008, there was an earlier internet draft along the lines of one of our current proposals. And although that was not adopted as an IETF consensus, a lot of implementations actually acted upon it in 2008 and 2009, resulting in fairly widespread software compatibility for unicast use of 240/4 today. And the lowest address we have gotten, and our colleagues have gotten, patches in the default current releases of Linux and FreeBSD. Our project has also gotten default unicast support for 0/8. Again, this excludes the 0.0.0.0 and excludes the 255.255.255.255, which have other special meanings. So these changes typically are very small. They typically consist of removing code that implements special cases within IP stacks and then testing interoperability. And we're continuing to develop and propose software patches to open source operating systems to change or make them capable of changing these behaviors. One thing that I think is very noteworthy is that many of these changes have already been made in existing systems without causing any particular impact or complaint or problem. And in fact, it's quite possible that you're watching this presentation right now on a device that's capable of routing 240/4 and treating it as legal address space. We've tried experimenting with this, for example, using 240/4 as private address spaces with NAT on Wi-Fi networks. Typically, clients other than Microsoft Windows worked fine out of the box with no special configuration. Now, of course, this is NATing this address space, so it's not a claim that this is globally routable or would be globally routable under current BCPs, under current RFCs, under current practice necessarily. It's a claim that hosts already supported out of the box, with Microsoft being the outlier among OS vendors there. So any attempt to bring these addresses into widespread use that would be public addressing rather than private addressing in unicast would need to be gradual because of backwards compatibility limitations. This is something that we would have derived, in retrospect, an enormous benefit from had we started the process in 2008 with the Fuller, Lira, and Meyer draft. If we had started the process officially in 2008, we would have much broader support now and have much more usable v4 space now. Since we didn't start it then, we ought to start it now in order to keep the option open for the future. There's a famous saying that the best time to plant a tree was 30 years ago, while the second best time is now. And I often think that that applies to some of our proposals. It's like planting a tree that hopefully will provide benefits to us in the future. And I know there's controversy about that, and I'm not going to have time in this venue to go into a lot of the controversy, but we would like to also work with the measurement community to get some metrics about how this all works if you actually attempt to do it, both in terms of hosts and in terms of operationally with networks. This empirical data can inform later decisions and debates about whether particular historically reserved address space can be allocated publicly. We envision that there would eventually be a debogonization process, which I like to analogize to the 1.1.1.1, which initially was treated as a bogon or a Martian by a lot of networks, and Cloudflare worked together with the community to change that very successfully. So there are a number of concerns from the community that we've heard at IETF and on the NOG mailing lists, often about the 127 draft. Now, different kinds of reserved address space pose different technical concerns when unreserving them. And I think it would be helpful if people would distinguish those. And for time constraints, I only am going to address, and probably about 10 or 20 seconds each really, policy concerns in terms of whether we ought to work on attempting to unreserve historically reserved IPv4 space, as opposed to technical concerns on how would we do it, how would it work, would there be certain obstacles or limitations to the benefits that we would derive from that. And I have also a fuller version of this, and I presented about a week ago at NANOG. And so one place where people can engage with that if you want to hear more about our responses to some of the concerns about this, you can look up my NANOG talk. You're also, of course, welcome to email us, and I have our email addresses in the last slide. So the biggest thing that we hear is, of course, IPv6. Why not just use IPv6? And I think that especially from the point of view of implementers, of software vendors, IPv4 versus IPv6 is a false dilemma because their IPv6 implementations are already complete. And IPv4 address scarcity pain continues to exist. We believe it's going to continue to exist for many years, probably for decades. And we'd like to mitigate some of the pain that results from the IPv4 address scarcity. There are some people who go so far as to say that no one should maintain IPv4 and no one should work on it. As far as we know, IPv4 is still carrying the majority of the traffic on the internet and is the internet's lingua franca and the most used network layer protocol. There was an attempt at an IETF consensus to entirely stop work on v4 and to designate it as deprecated or historical in the Sunset 4 working group from 2012 to 2018. And while there is strong IPv4 consensus that v6 compatibility is essential and should be expected of all new deployments and all new protocols, there is not a corresponding consensus that we ought to neglect v4 and that we ought to stop working on v4. And we think that that's appropriate, and that indeed that there is more likely to be a consensus in the other direction, that the IETF and the community still has responsibility to act as stewards of v4. There's a lot of economic value. There's a lot of pricing v4 addressing into the cost of hosting. Some people are actually happy about that because they think it will lead to v6, and we think that these things are not exact substitutes, and so this is not necessarily a v6 transition strategy. And so we've been doing some testing. I'm going to try to wrap this up in the hope of being able to answer at least one question. But again, we've been doing some testing. We'd like to work together with the measurement community, and we think that this is something that may bear fruit years from now, but that we ought to begin today. So you can help by trying out reserved addresses on your own LANs and test beds. Let us know if there are particular uses of these addresses, for example, as private address space, that you think might benefit from or conflict with our proposals. Support them or engage with us about them at IETF. Ask vendors to support reserved address spaces as global unicast. If you're an operator and you don't already run measurement nodes, for example, for RIPE Atlas, for NDT server, for KaiDa's ARC, we don't have commitments from any of these projects that they'll let us use them to test, but it's a good thing to do for network citizenship to host measurement nodes. And it's possible that we may be able to partner with some of these or other measurement projects to do empirical tests in the future. If not, getting more measurement nodes out there is a great thing anyway. And hopefully we'll be able to discuss on NOG lists whether there are tests that we can usefully do. Thanks. And I see 2 questions there, and I see that I'm really out of time, so maybe I can rush and attempt to say something about these. One question is about the 127, and I don't know. I think the question is why historically was all of 127 reserved for loopback? And I think it's really interesting to look back at some of these things, and I think the basic answer for a lot of these things is it didn't appear that scarcity was really going to be a big deal at that time. It didn't appear that a /8 was a big thing to allocate for a network function. And the last question is about how the previously reserved addresses would be distributed to the community if we're able to get these proposals accepted and have consensus about them. And I think that that's something that is still premature and is something that basically requires internet consensus processes. So the internet consensus process that we'd like to see go ahead right now is standardization at IETF in order to persuade all implementers and vendors that it would be a constructive thing for the future to treat less address space as reserved. That will give us more options down the road. So thanks. And please do take a look at my nanog presentation if you want a little more detail about some of the debates that have cropped up. And feel free to drop us an email if you have questions, comments, critiques, concerns, and so on. Thanks again for the opportunity to speak here at APRICOT.
Thank you, for your presentation and also answering the questions. Well done. So that concludes the session. Thank you for our 3 speakers, and thank you all for your participation. Hope to see you again in the future APOPS session. Thank you very much. Over to you, Philip. Do you have any announcement?
Only announcement I have is thank you very much, Maz, for chairing the APOPS session, and thanks to the 3 speakers, to Seth, Jeff, and Danny. It was, APOPS we always keep for some of the best presentations that are offered for us at APRICOT for the general common interest, and the program committee agreed that these 3 really deserved as wide audience as possible. So this is why we're here. So we really appreciate all of them. Thank you so much for that. All right, so this brings us to the end of the APOPS session. You'll have seen the conference poll pop up on the screen in front of you. So please give us some feedback about what you thought about the session. Otherwise, in about 12 minutes from now, we will begin the peering forum. So please stay on this Zoom session. It doesn't change. It's the same Zoom session. We'll carry on for the first of the peering forum sessions. And so that session is a panel discussion about internet exchange points in the Pacific. So please join that. As I said, it's in about 12 minutes from now. So in the meantime, enjoy the intermission break. Stretch some legs, refresh yourselves, get some fresh air, and we'll see you back in 12 minutes from now. Thanks very much, everyone.
All of the snow in this winter land used to look so pretty, now making me moody. In the deep
IPv4.global, from Hilco Stream Bank. Backed by Hilco Global, IPv4.global has completed thousands of transfers. Our online marketplace serves address blocks and ASNs of all sizes and regions. Transparent, experienced, reliable. IPv4.global.
You don't call your mum via a chain of other people's phones. So why would your Australian network be any different? One internet exchange service makes single-point national connectivity in the Australian market as simple as IAA. Carrier-neutral, high-performance, unmetered peering from IAA. Because Your users deserve it.
In Asia, the IP address management is managed by an organization called APNIC. Then, APNIC appointed IDNIC, APG, to run the IP address management process, especially in Indonesia.
Team Cymru delivers no-cost threat monitoring to internet service providers and hosting providers who partner with us. Nimbus Threat Monitor gives you near real-time threat detection, illuminating the compromised assets on your network and those of your clients by correlating your network flows with our world-class IP reputation data. Saving and improving lives is Team Cymru's mission, and making the internet a safer place is integral to that mission. Take advantage of our peer signal threat detection today.
All right, I was just waiting for the music to stop. So I'm not watching the clock too precisely, so just watching it reasonably closely just before we get started. So I believe we're still waiting for Tavita to join, but I think that's no issue. We can probably push on. So before I start things, actually, before I start, just to play around a little bit more, it's Shakiak's birthday today. Shakiak is our Zoom host, so I'd like to wish her a happy birthday on behalf of all the participants at the Peering Forum. So many congratulations. Right, so let's start.
Well, good morning, Philip, and good morning, audience. I'm welcoming you to the first part of the Peering Forum here at APRICOT 22. We do actually have a panelist who is yet to arrive, but all others are here and accounted for. Now, our topic today is of extreme interest to many of you in the region because it is about internet exchange points across the Pacific, especially in our smaller neighbours across that region. We do obviously have some representation from the Pacific Rim, namely our friend there from Japan. But our main topic here is to explore how IXPs help the internet in that region and building one and how that will actually essentially make internet services in those smaller countries much better. So we're here to basically sell you on the idea of peering, but also get you guys used to the idea that peering anywhere is a good thing. And I've been known to say that if you're not peering everywhere, you're not doing enough peering. So I'll now get on and introduce our panel. First of all, but not least of all, or not most of all, of course, is our good friend Chris Zane, who is from the University of Hawaii. He'll be talking about some of the more interesting things that have happened over the last decade or two with the exchange point in Hawaii. Then we have the very young but also very wise Jose Dante Santiago, who is from the University of Guam. And again, another a representative of what is happening with peering in the North Pacific regions. And then after that, we are waiting for Tavita Navalov from Fiji to arrive. I'm hoping Tavita turns up soon, but we'll keep the spot open. I also see we have Jethro from Vanuatu online as well, which is great to see you here. Another very important peering point here is PNG, Papua New Guinea. That will be we'll be speaking to Keith Anderson about how PNG IX has been developing. And then, of course, when I was discussing the panel privately with our group here, we said we needed to have someone who represented what success would look like. And of course, we have a very good example of that with JPIX, so Japan. So our good friend Masataka-san will be speaking with us at some stage today too, to tell us what is happening with JPIX, but also to show us how IX is mature into something that is of great benefit to the internet usage around it. What we'll be doing is we'll be giving each of our panelists approximately 5 minutes to give us some rundown on what they're doing with their IXP, who they are, what they have been doing during their career, and some funny anecdotes here and there as well to get you guys used to the idea that we have some human beings out there who are running IXPs. IXPs don't run themselves, which is great to see. But given that, I will hand the floor over now to Chris, who is coming to us from, I think, the Honolulu. Is it, Chris?
Yes, close enough. So thanks, Terry. Hello, everyone. Chris Zane from the University of Hawaii. I'm the engineering manager for the system-wide IT group at the university. We have 10 major campuses scattered across 6 different Hawaiian islands, and we connect those campuses up as well as key research institutions or sites such as Mauna Kea on the Big Island, Haleakala, where all the telescopes are on Maui. So a little background on the state of internet exchanges in Hawaii. Back in the mid 1990s, dial-up was pretty much the only way to get connected to whatever the internet was back then. In Hawaii, there were a number of dial-up ISPs that obtained their internet connectivity from various upstream providers that all had separate connections back to the US West Coast. So during those early days of the internet, there were no large data centers as we have now. So any of the content, the basic web pages, whatever the web pages were back then, were typically hosted on servers at these local ISPs. This meant that a user using a dial-up internet connection who wanted to visit a website in Hawaii may have had to send their packets to the US West Coast and back to get that content, since none of the local ISPs had connections to each other. You may have lucked out that your ISP happened to have the server sitting at their, the closet in their office, but more than likely not. So the university recognized that dilemma and started the Hawaii Internet Exchange, or HIX, in the late 1990s. We provided a frame relay T1 circuit now and a router, which was, I think, a Cisco 2501 back then, that allowed any local Hawaii ISP to create a frame relay permanent virtual circuit to the HIX router and establish BGP peering with HIX at no cost. The university paid for the circuit, the router, and the management of the exchange. HIX exchange routes with all the connected ISPs, and this kept local Hawaii traffic local and significantly improved the user experience. I don't say latency, because latency over a dial-up, it was pretty bad to begin with. Over the years, HIX upgraded to a DS3 frame circuit. We actually upgraded to a Cisco 7206 router, and eventually offered Ethernet up to 10 gigabits per second in the more recent years, with a Juniper instead of a Cisco 72. As the commercial internet grew and data centers and co-location spaces became established in Hawaii, the university decided to send all commercial entities that were peering to the local DR Fortress Internet Exchange, as we could no longer use state resources for commercial purposes. DR Fortress is the major co-location provider and data center in Hawaii. It's located down by the main Honolulu International Airport. So HIX still remains, but is focused only on state, local, and other government entities and research and educational institutions. HIX still maintains a 10 gig connection to DR Fortress IX to provide local peering to the commercial entities that peer there. In our viewpoint, HIX was very successful during the early days of the internet in Hawaii, and now continues to serve the state, local government, and research and education institutions to ensure that Hawaii traffic stays local within the island. Right, thanks, Terry.
Great, thank you, Chris. Jose, tell us about Guam, and I think it's, what is it, Mari IX, is it pronounced correctly?
Yes, it's actually MARIX. So that's the Mariana Islands Internet Exchange. Hafale, my name is Jose Santiago, from junior network engineer from the University of Guam. Relatively small campus compared to University of Hawaii, but the largest four-year institution here in the Western Pacific, in our region anyways. So we started MARIX in 2018. So our IX is relatively young in age and experience, just like I am. But we're still growing with the gracious help of folks like Philip Smith from NSRC, and as well as guidance from Chris Zane and everyone else in the region. Just talking with everyone and seeing what we can do as the IX to help improve the internet on Guam. Our goal is as a open internet exchange, carrier neutral, to connect all the ISPs on Guam, because we had the advantage of that all of their fibers. We had fibers running from all the ISPs into our data center to provide internet for the university, as we go through our yearly procurement of who gets to provide bandwidth for the university. So when we stood up MARIX in 2018, and we were able to get all the ISPs instantly connected to the IX, And going to conferences like APRICOT, APNIC, we were able to talk to other people, and we also got Hurricane Electric connected here. And just recently, last month, actually, we got Japan-wide's MRoot stood up here at university at the Marix. It's been a lot of challenges standing up an IX as small as we are, as the IX is only partially funded from the university. As Christine was explained, that we couldn't fund, the university can't fully fund the IX as a commercial entity. And so we have to get donations for some of the equipment. NSRC actually donated 2 of the route switches for our IX, and some of the routers were some swapped out routers from the university. We started off with a Cisco 2821. Now we're using a more beefy Cisco ASR 1001X. Some of our services are still in the works of coming up. We actually hope to bring the CCTLD that the university does also operate and manage, the .gu domain, into Marix. We find that commercializing the .gu domain in that entity as that Marix is the best way for it to market itself rather than from the university. So yeah, that's our experience with Marix so far. It's still up and coming, still growing. Hopefully we can get more peers to connect with us. The unfortunate disadvantage we have is that our IX is at the data center at the university. And so getting more customers, more members up here is somewhat difficult without having to tack on carriers to bring their fiber connections for customers over. And maybe we'll toy with the idea of bringing Marix closer to the edge at some of the landing stations or other co-location data centers so we can get more people to peer with us openly and hopefully increase or enhance the experience, internet experience for people of Guam.
That's awesome. I'll remember to ask you at the end of the panel about the CCTLD stuff as well, because that's a bit of a project of mine for other people. So that's good. I'm not sure if Tavita has logged in yet. I know, no, we don't have Tavita. So Jethro, how are you doing? Are you there? Can we hear from you now about Vanuatu? Is Jethro here? Yes, yes.
Hi, Terry. Firstly, thank you for this opportunity that I have to speak at the APRICOT and to be part of the panel discussion on my XP. Yeah, my name is Jethro, and just a bit of background. I worked previously for a telco, local telco, and later on I joined the government to work with the broadband, government broadband network. And while with the government, that the idea came up to set up the local IXP. And that was way back at the end of 2012, that initial discussions occurred to start the IX. And in 2013, first members established peering at the IX, and later on others joined. So initially we started off with about six members, and then later on one of the ISPs got bought by another one, and another one got like they are not in business anymore. So at the moment we're left with 4 members. So initially not everyone were keen on the idea, but later on they saw the benefit for the IX and they came on board. And so at the moment all the local ISPs are on board. And phase 1 we got everyone connected. We also managed to get some contents into the IX, also got a few root servers and a Google case, and had some discussions with FB regarding the case as well. However, we did not really succeed into the next phase where to get contents into the IX. So we succeeded in getting everyone on to connect. And I think that would be due to, I would say, one of the main issues at the moment with us is to strengthen the IX management-wise, so strengthen the management for the IX, and then perhaps with a strong management on, then we could really move the IX forward. And so, yeah, that is something that I see as the main thing that affects our IX at the moment. Yeah, currently, as I've mentioned, there's only 4 local ISPs and none of them are currently connected. And yeah, perhaps I stop for now and perhaps have some more information for later. Thanks.
Well, thank you, Jethro. Yeah, I think we'll definitely ask you about the content question at the end of the rest of the speakers. That's a very good topic to canvass with the panel as well. So next up, we have Keith Anderson, who is, I believe, located in Port Moresby, and is, achieving a few things with the PNG-IX. So over to you, Keith, if you're ready.
Let's try that. Is that any better?
That's perfect. Thank you. We always have to have someone do a little bit of Zoom fail, don't we? Yeah, always good. Always good.
Got the new headset plugged in and didn't unmute it. But anyway, no, we're actually over in Madang today. We had a flight this morning, and we're doing some work here where the second PPC-1C cable lands. So we're over here, and luckily we're on the country's data cave fiber to get back. But back to the real thing. So I've got internet experience when I started my own ISP in Australia back in about '98. The company that I owned then was a meter reading company, and we had ISDN lines all over the country reading electricity meters, and the internet came along, and we thought, well, let's try out this internet thing, and we haven't gone backwards since. And from then, in about 2000 or 1998, we came to New Guinea, and we built the country's first ISP, which was a company called Daytech. They brought the internet into Papua New Guinea. So we built that up. We built proxy servers. And then I came back in about 2013. And after watching hearing groups start up in Australia, the likes of Pipe, etc., I started pushing to get an IX here in Port Moresby. So it was very hard to get the ISPs to communicate with each other. Everyone was, thinking someone else was going to get a bigger benefit than the other person. The bottom line is everyone benefits. It's worked out really well. It took probably 2 years to get people to connect, and the last piece that really helped was when APNIC and NICTA, the country's regulator, got on board. And that just sort of helped us get over the line. We set up a non-profit company. We're still non-profit. We don't even have a bank account. Everyone donates their time, their services. All the ISPs donate engineers to come in and do work. And it's working quite well. We've got interconnects now with Google in country, interconnects with Facebook. And last year we set up our second exchange point over in Lae. And we're setting up a third one now in Madang in the highlands, because connectivity throughout the country is very hard and very limited. So we're finding all of these extra points of presence where we can put in Google and Facebook interconnects and connect with them directly. It's really helping get some real bandwidth and some user experience that's really good in country, because the links in country are very, very limited. That's sort of me in a nutshell.
Oh, thanks, Keith. That obviously we've got a common theme with content being on the exchange, so that's definitely something we'll talk about in the second half hour. Now, As I alluded to, we do have our exemplar here, and that will be JPIX. So Masataka-san, I believe you have a slide deck to share with us as well to give us a general overview of what JPIX is doing. So over to you. Welcome.
Thank you for introduction, Terry. So I'm Masaka from JPIX. So today I'm glad to be here for this panel session. So I'm a network engineer in charge of building and maintaining IX backbone network in Japan. So as you may know already, so JPX is a commercial internet exchange in Japan. So maybe it's a different point from other panelists here. So, but Japan is an island country in APAC region. So I'd like to make a comment, maybe a different point from others. So I would like to briefly introduce JPIX with introduction slide. So can you see my screen?
We can see your screen. You just want to put the PowerPoint in presentation mode and away you go. There we go. Okay. Thank you.
So we are operating a 3 IX network, Tokyo and Osaka and Fukuoka. So we have three network as a peering platform. So and this is JPX overview, like peering personal slide. So as I mentioned, so we have 3 networks, Tokyo and Osaka and Fukuoka. So and there is point of presence in each area. So and there is a number of connected ASNs and peak traffic. So yeah, as I mentioned, JPX is a commercial internet exchange. So we have been established since 1997. So we have some shareholders. So I believe JPIX is a neutral internet exchange in Japan. So and this graph shows the number of connected ASNs. So for now, we have around 250 members in JPIX Tokyo and Osaka. So and we have JPIX Osaka. So it has around 100 members. So this is traffic volume graph. So we have around 2 terabit per second as a peak traffic volume. And another graph is JPX Osaka traffic volume. So it will reach 1 terabps soon. So yeah, so as I mentioned, so JPX is a commercial internet exchange. So in the panel discussion time, so I'd like to some comment by commercial internet exchange in Japan. Thank you very much.
Oh, thank you very much, Masataka. That was a great overview. I like the graphs. Definitely answers the questions about traffic levels in your IX as well. I think a lot of us look at those terabit per second graphs and feel real envy when we see those. So that's great. I think one of the first themes that we've obviously uncovered already is the role of content on the exchange. And I know Keith has alluded to it, and Jethro has also lamented the lack of it as well. So if there's anyone on the panel who wants to address the issue, what does having major CDNs on the exchange do for the exchange? How does that improve things, and how does that make end users' experience better? So if you any two or three of you would love to talk to that now, please raise a hand. Keith.
No hands, so we may as well put one up. So when we're looking at traffic in Papua New Guinea, Port Moresby, the ISPs connected, and we only had 3 connect really from day one. And the amount of traffic between each other was just hardly worth it. Maybe 1 or 2 meg with a little bit of web traffic and a little bit of email. So really, for the first 6-7 months, all we were bubbling along with was under 10 megabit. Today, with Google and Facebook, we're exchanging 6 gigabit. That only happened because of the content. There's really not that much more extra content or websites between each other. It really is the Facebooks, the Googles, the YouTubes, all of that content. And that's now contributing to 30% of the country's traffic. I shouldn't say the country, 30% of Port Moresby's traffic, because we can't reach out really past that with our limitations that we've got. But 30% of the traffic in country is, one, a huge saving. We look at the internet prices here in Papua New Guinea, it's probably 2,000% above Australia. So getting that much internet exchanged to each other at that lower price really helps the end user, helps the country, and especially the end user's experience. Mobile phones that naturally have got a little bit of latency between the phone and the tower. Instead of that, then heading back to Australia to get its content, it's pulling most of its content, cached content in country. And that user experience is huge. It's really felt, and a lot of people comment on how much better it is.
Oh, Chris, thank you. Go for it, Chris. Go for it.
So the university, especially in light of the pandemic, when we had to switch to online learning, the university has its learning management system. And the students who are now at home on broadband connections or mobile kept their traffic local within Hawaii, as we peer at the DR Fortress IX, as well as we have direct peerings with the local cable company and the local exchange carrier that provides 90% of the broadband connections to Hawaii. So by having those local peerings, when the students were home during the pandemic and they had to reach out to the learning management system, it significantly reduced the latency for them, and it made the user experience a lot better. Unfortunately, Zoom is still on the mainland, but there's not much we could do there. But it was tolerable, I would say, and it actually worked pretty well. And we're glad we had the local peerings during this time period.
So any more comments from the panel, or shall we go to the Jose? Yes, please.
So kind of similar experience that Chris just mentioned with the pandemic, that when we went to online learning, one of the first things that we did was we stood up a service called BBB. This is a Big Blue Button, part of our online learning platform through Moodle. Since we don't have Zoom on island, the students would still have to go off island all the way to like mainland or Hong Kong, whichever server the Zoom was being hosted on. But through having a locally hosted BBB server, it cut down latency immensely because it kept local traffic local. And since you have all the ISPs, it did not matter if you were one provider versus another. Since all of them peered at our IX, it was all media came into our data center for the resources that needed. Having content at our IX for our users is very significant. one of the one recent thing metric that Japan-wide helped us find out was when we stood up their en route server, in order for us to reach a resource in Tokyo, went from 87 milliseconds down to 0.82. That's a drastic change. And so if we can just mirror that concept, like, okay, so what other resources can we have at RIX that our users can make use of locally, the experience will be so much more better for them. We're on the brink of turning up Cloudflare as well, paired RIX, and we're already seeing some traffic going there. There's some locally hosted websites there. And so we can expect people's experience for some of the content caches there to be exponentially better. Not to mention some of the ISPs do host websites for their customers. And so the inter-exchange for there, they probably have their own backend peering as the local ISPs on such a small island. Undoubtedly, they probably have their own private peering at their own data centers. But to have a redundancy at RIX, we've even heard that the path through RIX is a shorter, much more better path between their communication exchanges. So that's what I have about content.
Great, thank you. Yeah, Jethro, I was going to ask you the question. You've just heard from 3 panelists about what local content is doing, and I believe you did say I'm missing local content. So what are your thoughts now? What do you think you now need to go and get for the Vanuatu IX?
Yeah, thank you, Terry. Actually, we deployed Google Cache after we saw that the IX, and initially it started serving traffic to ISPs, but then we had an issue with IP transit bandwidth, and that has been the issue since day one, where they come up with an agreement of how to slot for the IP transit bandwidth, and that sort of like the main looking point was getting more content in, because it requires IP transit. But when we tested out Google Cache, we deployed it, and one of the members was using it. It was very good. Getting fast videos from YouTube and so forth. So yeah, we saw the benefit of it, and so I was trying to get connected to the case, and unfortunately we couldn't reach a point how to sort out the IP transit cost, and yeah, that has been the issue. We've had several discussions on that. Unfortunately, we couldn't work out in a way forward with that. The benefit of the IX, as the other panelists mentioned, during the pandemic, yes, it really helped us when people started working from home using VPNs, and also with some organizations that had their own hosted video conference platforms locally. So when they used other ISPs to connect via VPN back to the network, it was very good. So yeah, I think one of during the pandemic, people really see the benefit for the IX.
Right, thank you. I think we'll start with some audience questions here. We did actually have one come up from Dave. Where is that question from Dave? Okay. So Dave did ask, how much of a problem does having monopoly last mile providers create with encouraging peers to join the IX? And I think this is probably very relevant to the markets which still have either a small number of last mile providers or have only one last mile provider. So I'm assuming someone will probably have a comment about that. Possibly Jose, possibly Chris, possibly, yeah, Jose, please.
Yeah, so I mentioned it earlier in the introduction. Given how our RX is located at our university data center, we don't have access to the landing stations to reach all the other international providers and potential customers. And so getting them to our data center is extremely hard because they would depend on paying the local carriers infrastructure to transport them to our data center. And so that's an extra cost on them on top of what they already costed them to bring their connection to our shores, our landing stations. And so for us, I guess one way for us is to branch out or extend our IX to those landing stations, to those co-location centers, that we can be more easily accessible to the customers. Because if you look at it from a business standpoint, right, whatever you can make it, if you can make it easier for your customers to connect to you, the more customers you'll have. That's, I guess, one thing we can comment about that.
So any other panel members, your regulatory environment around you, does it make IX entry harder or easier, or what is the situation? Jethro or Keith, do you have any comments about that?
Terry, we comment here. In our case, ISPs set up their own links to the IX without having to go through via another ISP. So yeah, so we did not really have that issue here with that.
Cool. Another question that's popped up too, I think Keith has already engaged with the questioner, but it's worth a while answering it. Essentially, it's if you're running a CDN network on an exchange point, you still need some sort of transit service to feed the content into the CDN. And I think it's Ville has asked that question. So Keith, did you want to answer that question on behalf of PG and IX?
Yes, happy to do that. Here, the cache fill was a problem, and there was arguments in relationship to the cache fill. So what we worked out was that the cache is really 4:1. So for every meg you put in, we're pulling 4 meg out of it. And we've just put cacti graphing on everybody's link. And if you're pulling 100 meg, you have to pay 25 meg for cache fill. And that's working quite well. The members are happy with that. Everyone, someone might get a bit extra 1 month, but it really doesn't matter. It does average out over the year. We've done the same with Facebook and Google, who we have to do cache fill for, and the members have agreed to it, and they actually pay the upstream provider directly.
Well, that is actually a really equitable solution overall, isn't it? Because exchange points are about sharing not just traffic, but also costs and essentially gaining a collective benefit, as opposed to everyone tries to run their own operation. The internet is the internet of all networks, so having everyone try to behave like they're not connected to anybody else sort of defeats the purpose of even running an internet service provider business. So yeah, it does make things interesting. We're getting towards, I think, our last 10 minutes or so. Masataka-san, I'll tap you on the shoulder now, because I want to get your input on where IXPs are going as far as commercial operations are concerned, and how development is happening in IXPs in general, as you alluded to in your presentation. So if you could please give us your best wisdom on this. Thank you very much.
Yeah, so regarding Japan situation about our industry. So as you may know, so there are several major tech companies in Japan, KDDI, NTT, and SoftBank. So their company have IXP company. We have good competitive relationship. So our engineer can talk with other IXP engineers. So it's good relationship. So about lower latency and shorter path. So I have slide in relation to that. So this slide shows what the JPX provides for our users. Content cache topic is on second point on this slide. So we have a shared cache server. It's Akamai is deployed in our network for our JPX users. So and eyeball networks can afford their traffic to IX port. So and about situation under COVID-19 pandemic situation, so there are traffic volumes spike by new release of game content. So it's a kind of like hard to control their traffic in their network. So, and I would like to introduce another slide. And this slide shows traffic graph, and this is about shifting traffic volume to IX. So it's a case study of cable TV internet provider. So its traffic changes before connecting IX and after connecting to JPIX. So after connecting to JPIX, their cable TV internet traffic move from transit providers to IX. So it make saving cost about their network. Thank you.
Just a quick follow-up question. I see that's 2.8 gigabits per second. What sort of monthly cost would that have been on their transit bill in Japan? That would have been a significant amount of cost for them to move onto the exchange and effectively get the traffic for free, wouldn't it?
Actually, so I don't have detailed information about actual cost. But originally, so they had 5 IP transit from transit ISPs. So I think you can decrease IP transit circuit after connecting to IX.
So quite possibly they would have saved on a whole contract by the looks of this chart. So yeah, that's a very significant difference to them straight up. Yes. Now I'll quickly find if we've got any other follow-up questions. I do know that Mark Pryor was asking if there are any providers missing from a particular exchange, but I believe that's been answered in chat already. Apart from that, I think we have addressed nearly every single question in the chat. I think now that we're at this point, we can probably start looking at some summaries. We've got about 15 minutes left. I'd love to hear from more of our viewers of what they would ask of a peering exchange and how they would address any problems. But I believe one of the questions I noticed I did give to our friends here is about business models, and we've already heard that, for instance, JPIX is a commercial operator. Keith has told us how PNG-IX is a non-profit. I believe Vanuatu-IX sounds like it's also operating under the auspices of OGCE, is it? I think, as well. And Jose has the similar issue as the University of Hawaii, where we can't always have everything funded out of pocket, and donations and other inventive ways of funding the IXP are actually needed. But if one of you would love to talk about what is the business model that you have to use, or the business model you would like to use, I'd love to hear about that. So.
For us, it is similar to Keystone, where we're a nonprofit, open exchange. Really, for the end goal is just to benefit the Mariana Islands, as our name is, the Mariana Islands Internet Exchange. The Mariana Islands is a archipelago of islands, starting from Guam, Saipan, Sianamai, 13 islands, 15 islands. And so if we can improve the internet experience for all our citizens in our region, we'd achieve their goal. And anything above that would be a pleasant surprise welcome.
No, that's a very good point, because it does, because of the aggregation effect of an IXP, you would expect that it's very much a common good enterprise. And I think, yeah, it does get to the point where it becomes a commercial operation, because most of the operators are commercial. But ultimately, if you want to start and grow one in the region, you need to be looking at a non-profit or beneficial society of some kind in order to get the IXP up and running. One of the other things I was alluding to before is the idea of a CCTLD. And it's something that I've personally done some studies on myself with the region, and it's something I'd love to get some input from, especially for you guys who are out there in the islands. What is happening with your CCTLD, and who's putting content on that? How is that developing? How is that benefiting your local culture and country?
I'll go first on that. Since I did mention earlier, the .gu Guam domain. Funny enough, most of the people, or most of the organizations or entities applying for .g domain are these bigger name companies like Chanel or Domino's Pizza. They want to make sure that they maintain the vanity of their name, and so they're just going out and buying up the domains, and whether or not they use it or not is up to the discretion, but they just hold on to it. There are a few local companies and agencies that use the .g domain, but not so much. They're still kind of driven to the .com. But hopefully, as we grow, the .g domain's been kind of small in terms of advertising on using it. But I think as the world of the internet is growing, I mean, you're seeing new domains like .tech or .io or .gg for gamers. I think the straying away from the .com domain and moving over to being more proud of who you are, where you're from, and owning a .gu domain for your website will start becoming a popular thing for people to start, or businesses to start applying for. So right now it's kind of small, but hopefully we're growing it. We'll grow it out as the IX grows out as well.
Now I'm hoping Jetro is still there. He's turned his video off, but I'd love to find out what his thoughts are on, I think it's the .vu domain, if you have comments for us.
Thanks, Terry. Yes, for one, it's the .vu domain, and currently it's looked after by Newstar, and so they've just recently established peering also within our IX. So request for views be through the IX. So that was part of the agreement that when they take over management for that view, they have to establish presence at the IX also. Apart from that, we in the IX we also have the DO server and the IO server also within the IX and serving everyone else in the country.
Yeah, I get to talk about CCTLD in one of my talks here at the conference, so I'll spill some beans then, but it's good news for many of us. Look, we have approximately 10 minutes left. I would love to encourage anybody else who has a question for our panel or would like to have a quick banter on screen with our panel as well. I'd be happy for anyone to take us up on that. If we don't get any questions, then I'll get the panel members. If you have questions for other panel members, or you would like to finish off with a general comment about how our discussion's gone today, that would be great. But okay, what are the security considerations that IXPs in the Pacific need to consider? That's come from Robbie Mitchell. So that's a great question. So if someone would like to take that one on straight up. Chris, you've been in this game for a long time. What do you reckon? What are the security considerations for IXPs?
That's a good question. I'm not sure that we've actually really looked at that. The whole internet exchange kind of is a free-for-all exchange point, and we push the security towards the end user who is peering with that. And since the one that we run is all local and state and research education, we know everyone, and there's really no internet transit occurring over that. So the security risk level is a little bit lower than most, I would think.
So Jose, yes, please.
Yes, so coming from a standpoint that the RIX is run by a university, universities tend to be targets since we do hold a lot of user information. And so we take the approach that we should be protecting ourselves from the anyone on the IX. Since it is an open game, it's open connection, anyone can exchange traffic however they like. The only thing that we'll do is protect ourselves. So we'll make sure that we protect our servers that we're hosting on at the IX, any services we're hosting, and also ourselves as connected members. We need to make sure that our filters, our access point, our ACLs are all, blocking all the bad stuff, following best practices, RFCs, and all that. So, yeah, it's protect yourself and assume everyone's bad on the internet.
Indeed.
Kind of idea.
If I could add, Terry, while on the issue of security, we have an experience with one of our members where I think they are sort of so concerned about security. They had a lot of ACLs on the router that these ACLs instead is causing a lot of issues for them with connectivity to the IX and to the other networks. And so, yeah, while security is important within the IX, like in our case, this one member here, perhaps they added too much of the ACLs or whatever, that in the end it's causing some issues again. But I think one of the main things to ask with the IX is regarding security or things like that is to ensure that your prefix filters, you allow the correct prefixes in that you should be getting from your peers and not getting chunks or whatever, as this advertising prefixes that shouldn't be, can cause problems for you as well. So I think on the side of getting the prefix filters set up correctly, that would be important. Thank you.
I think one possible concern is route leaks to the IX. So, on our side, we do the basic level, watch out for default routes and things like that that come through. The other one that works fairly well, and it's not a whole lot of work, is maximum prefixes, so someone doesn't dump the entire internet routing table across the IX.
Yeah, so there's a layer of security considerations there, which is of interest. Natasha has been very kind and sent me a couple of different questions. So I'm going to get to cherry pick now because we've got the 5 minutes remaining. But yeah, he's is interested in long-term sustainability, especially given some of the operations are not for profit. And I think that's a very good question. Is, you know, what are the prospects for some of the smaller exchanges ongoing as a non-profit enterprise? How will they sustain their efforts over time and possibly grow with the market around them as well? I'm not sure who's probably the best one to answer that one. Or maybe Keith, what do you think? Where will PNG IX be in 5 and 10 years' time? Is a very pertinent question.
You can sort of tell the future here. Being in Australia, having an ISP back in the early 90s, and I watched it, how it's growing over here, which is pretty much nearly the same. I think in the next couple of years, we'll see PNG actually double in bandwidth every year, like we see in Australia. We're not seeing that yet. We are seeing it climb, but it's not getting that doubling effect yet, and that will happen. More competition is needed here to try and get the bandwidth at an affordable price for the public. The internet here is still very expensive, so if we can get that price down, this country will be very hungry for learning content, and that would really assist the country. I see the IXs in this country, if we can get more content on board, and it's very hard to entice these content people. If the content is here, then we can distribute it at a cost-effective price. At the moment, the services aren't used because it's just far too expensive. Now, even if we look at the small ones like Netflix, nobody's going to watch a movie because it's going to cost you $20 to stream it. But if it was at the IX, we could stream it for 50 cents or whatever. So it's the chicken and the egg. It is very hard to get these bigger players into Papua New Guinea, but I think they will come. And because there will always be less competition here with limited sea cables, the price of internet will relatively stay high for quite a while yet.
Okay, we're getting towards the last 2 minutes, and I think if you do have anyone has further questions, I'll let Robbie and Tashi punt them through to conference@apricot.net, and we'll get some offline answers to some of those questions for you. But we're now at the stage where I will try to give you a brief summary of how we've gone with the panel today, and also thank the panelists. So I think what we have shown today is that there are definitely different business models and different ways of growing your IX, but the common factor seems to be is getting traffic onto it and demonstrating the benefits, not just the financial benefits, but also the technical benefits. I think that's one of the big things that a local IXP always does for local service providers is the shortcut and the lower latency, the greater bandwidth, which tends to be almost of no incremental cost whatsoever when you are attached to an IXP. So that is always amazing. For those of you who thought that the hour has been a sales pitch for peering, yes, you're right. This is a peering forum. Yes, you should be doing more peering. Just keep that in mind next time you go to design some of your new network. Are you doing enough peering? Are you not doing enough peering is a bad answer. Can have a bad answer in the boardroom. So remember that. I would like now to just go back around the panel and just say, look, you guys have been amazing. I think we've basically got representation from the old and the new, the developing, and so on. Great to see Jose and Chris, Masataka and Jethro and Keith here talking about what they've been doing with their IXPs, in some cases for a couple of years, in some cases for a couple of decades. I'm absolutely amazed that we got this panel together and we got you guys into the room to talk about this. It's been a really good session, I think. And I think we've done a very good job of basically telling people peering is great. As I think ongoing, if you do have further questions, I believe Tashi and Robbie have put that in the chat again to send off questions at conference@apnic.net. I would encourage you to do some more research in this area. Go and have a look at PeeringDB, join some of the forums coming up as well. You'll see we have peering personals from IXPs, CDNs, and ISPs coming up in the sessions following this one. It's always a great way of finding out who's out there and what they're doing. Those one deck slide decks they come up with are great because they normally have a few vanity metrics on there. So it's good to see those as well, to see what we can aspire to as newer IXPs and newer ISPs as well. But yeah, look, thank you all for attending today. Thank you all for my panelists. You guys have been great. It's been a great session. I'm very, very happy that we've got this hour done and we've got some brilliant content now on YouTube for people to look at. Thank you very much.
Yes, thank you very much, Terry. I just want to echo everything you've said. What a brilliant panel discussion. I mean, this was way better than I think any expectation that we had when you first proposed it to the program committee. So I really appreciate the effort that you've gone to pull it together. And it's great to see the panel members and everything they've had to share. So bravo to all of you. This has just been a wonderful session. Thank you so much. So this brings us to the end of the first peering forum session, which was the panel discussion. We're going to have a 40-ish minute break now. That'll be a new Zoom session after the break. So this one will finish basically once I've finished speaking and the outro slides have stopped. So please go and enjoy your break, your breakfast, your lunch, your dinner, wherever you are. And we'll see you back in about 40 minutes for the second peering forum session. And as Terry mentioned, part of that will be peering personals. And I think the team have gathered, I forget, about 50 peering personals that are going to take place over the two sessions. So please enjoy your break. The session poll, did the session poll happen? I don't remember seeing it, but anyway, there'll be a session poll popping up in a second. Please let us know how that went.
I haven't seen the session poll yet, actually, so yeah.
So don't know what's happened to it, but anyway, it'll appear. So when that happens, please fill it up. There'll be short outro slides played and then the Zoom session will terminate and we will see you back in about 40 minutes time. Thanks very much, everyone.